let's talk about vector products in this video. So we have already discussed about scalar product. Scalar product was if you perform the dot product or the scalar product operation on two vectors, the output was a number, normally a variable, and it's limited as x. Yeah, but when we are performing vector product, the output is another vector. Okay, the output is another vector. And the special part about this vector is that C will be perpendicular to A. At the same time, it will be also perpendicular to B. That's the important thing that we have to carry away from this specific operation. So, if you want to imagine this, okay, if you want to imagine this, let's say we have A in this direction and B in this direction. Okay, so if you have in these two directions, A and B, if you apply the right hand Fleming's rule, okay, and in the direction, first of all, the order matters. Okay, so if you are finding A cross B, okay, if you are finding A cross B, if you apply the right hand Fleming's rule, here you have the A in the A will be depicted by using the index finger. Okay, A will be depicted using the index finger, and B will be depicted using the middle finger. So your thumb will depict uh, the vector product A cross B or C in this case. Okay, and that will be perpendicular to B as well as A. Okay, so this will be A cross B. Okay, so if you want to imagine this, let's say this is your index finger, and this will be your middle finger, and this will be other fingers, and your thumb will look something like this. Okay, I know this looks really weird, but yeah, you can try this on your own. Index finger represents the first specific vector. Middle finger represents the second specific vector. Thumb will be the output of A cross B or A into B. Okay, so that's what we have. So why did I say the order matters? Well, if you look at here, if you have B into A, okay, if you look at B into A, let me erase this. Okay, so we have to take B in the index finger and then A in the middle finger. So now B cross A will be in the opposite direction. B cross A will be in the opposite direction. Okay, so this will be B cross A. B cross A. Okay, so this will be B cross A. So A cross B is not equal to B cross A. We studied that in scalar product. A dot B is equal to B dot A, but it's not true for vector product. Okay, the direction changes. Even though the direction changes, B cross A is also perpendicular to A at the same time perpendicular to B. Okay, so only the direction changes. Okay, so if you want to keep this a little bit easy for you, okay, if you want to keep this easy for you to understand, just write this down as A dot A cross B is equal to 0. Why is it equals to 0? Well, A is perpendicular to A cross B. So according to the scalar product, okay, according to the scalar product will be equals to 0. Similarly, B into A cross B will be equal to 0. Okay, so why do we need vector product? Well, let's say you have two vectors and you have to find a perpendicular vector to those two vectors. Well, voila, you have vector product to find the perpendicular vector for the given vector. Okay, so that's what we are learning here. So here we have a specific computation to do. Okay, there are multiple ways to do this. You can memorize a specific, equation and you can apply that. Or here you can apply the determinant way to find the vector product. Okay, so let me write down a practice question for you at first. Write this down in the determinant form with the unit vectors as the first row, I, J, and K. Then what you have to do is you have to write down A components first, 2, -3, and 4. Similarly, here you have -1, 5, and 2. Now, let me introduce you how to perform determinants. Okay, if you have determinants, what you have to do. So if you have something like this, A, B, C, D, E, F, and G, H, I, okay, in determinant. What this does is you have to, this can be rewritten as A into EFHI, okay, minus B into DFGI and plus C into DEGH. Okay, so what am I doing here? What's this random code? Well, if you have to write the A first. If you have nine specific values, which means 3 into 3, you have to write down A first. Well, you will cut out these two and you will cut out these two. That's what happens. So you'll find A into EFHI. Okay. And then minus, you have to put minus. If you put plus for the first specific uh, value, okay, if you put for the plus for the first specific value, you will put minus to the next value. Okay. So you put minus and then you will cut out these two values. Okay. And these two values. Okay. So you will have D into DFGI inside the determinant. Okay, then you will put plus again, plus minus plus, plus C into, instead of, you will cut out A, B and Fi and you will have DE and GH. Okay, so this is what you do when you have 3 into 3 determinants. Now what do I have to do? Okay, we have decomposed into 2 into 2 determinants. What should we do here? Well, after this is fairly simple. This is the positive direction and this is the negative direction. Okay, so you will write A into EI minus FH minus B into, here also, this is the positive direction and this is the negative direction. So DI minus GF. Similarly, here you will have C into DH minus EG. That's it. So if you simplify these values, you will find the output of the given value in terms of A, B, C, and then the other letters. Okay, so that's what we are going to do here also. This is a very important idea in matrices. Okay, and we know matrices is really close to vectors in physics. So keep maybe it's better if you do in this method rather than the other methods presented to you. Okay, this is fairly easy, and this method you will apply in multiple cases if you are going to survive in IT industry. So yeah, just practice this method. So I'll do this one for you. Okay, I'll do this example for you. So you will have I into, okay, minus 3 into 2 minus 4 into 5. Okay, then minus j into 2 into 2, okay, minus 4 into minus 1. Okay, so it will be, let's write that down. Minus 1 into 4. Okay, let me erase this. Since you have taken notes, we can go to the answers now. Okay, fine. So now we have k into 2 into 5 minus minus 1 into minus 3. Minus 1 into minus 3. Okay, so now you can see I into minus 6 minus 20 minus j into 2 into 2 is 4 and minus minus 4 will be plus 4 plus k into 10 minus 3, so it will be 7. Okay, well, let's write that down for now. 10 minus 1 into minus 3, 3, since we have minus here, minus 3. So the final answer will be minus 26i minus 8j minus, sorry, plus 7k. Okay, so the vector that is perpendicular to A and B can be given as minus 26, minus 8, and 7. And if you apply the dot product, and if you have the dot product of A into this value, let's say this is equals to C, yeah, in this case, let's say that is equals to C, well then, okay, the dot product of A into C will also be equals to 0. At the same time, B into C will also equals to 0. First of all, A dot C. So A dot C will be equals to 2 into minus 26 minus 52 minus 3 into minus 8 plus 24 and 4 into 7 plus 28. That is equals to 0. So which means A is perpendicular to C, which means the values are correct. Now let's check for B dot C. Now, minus 1 into minus 26, it will be 26. 5 into minus 8, it will be minus 40. 2 into 7, it will be 14. That will be equal to 0. So B is also perpendicular to C, which means B is perpendicular to A cross B. Okay, so this is how you can recheck whether you are doing in the correct way. This is how you recheck whether you are doing in the correct way. Okay, now let's do a practice question. Okay, now let's do a practice question. Try to do it by yourself. So if you have to do x cross y, first of all, write that down in the determinant form. I, j, and k. First of all, you have to write x value 3, 4, 0, then y value 10, minus 5, and 20. So this will be equal to I into 80 minus 0, so it will be 80, minus j into, you will have 3 into 20, 60, minus 0, so it is 60, and you will have plus k into 3 into minus 5 minus 15, 4 into 10, but we have to add a minus before, so it will be minus 55. Okay, so here you will have 80i minus 60j minus 55k. Okay, so this is the value of z. This is the value of z. If you have to check, you can check x dot z is equals to 3 into 80, 240, 4 into minus 60, minus 240, 0 into anything, it's 0. So it is equal to 0. Similarly, y dot z can be given as 10 into 80, 800, minus 5 into 60, it will be plus 300, 20 into 55, 2 into 55, 110, 1100, so minus 1100, it will be equal to 0. Therefore, the answers are correct. Okay, so this is what I wanted to cover in this video. In the next video, let's focus on the properties of cross product.
Thanks for watching the 20-second video in our vector series. If you found this explanation of the vector product of vectors helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. Follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.